Okay, we are starting chapter 10 in pre-calculus 30, so we're going to look at function operations today. So we'll quickly start with a little warm-up here, just to refresh our function skills. So for each of these, name the type of the function, the main characteristics, and draw a sketch of the function. We'll do this really quickly. This is a linear function, and the main characteristics of this function, well, it has a slope of 2, so 2 over 1 is your rise over run. It has a y-intercept of -4, and I guess if you wanted to talk about the end behavior, it starts in quadrant 3 and goes to quadrant 1. It's a pretty simple linear function. This one, because of the presence of this 2, this is a quadratic function. Some things we can pick out quickly. It has a vertex at 3 and 4. It opens down. And what else do we want to say about this? I guess we could find the y-intercept and or the x-intercepts. So let's set y equal to 0 and solve. So 0 equals -1 times x minus 3 squared plus 4. So -4 equals -1. I'm just going to drop that -1 over to the other side, and we get x minus 3 all squared. Just expand this, and you get x squared minus 6x plus 9. Now, I guess I should have left that 4 over there. So x squared minus 6x plus 5. So this is going to be x minus 5 times x minus 1 equals 0. And your x-intercepts are 5 and 1. And for your y-intercept, plug in x equals 0. So y equals -1 times 0 minus 3 squared plus 4. So this is -3 squared is 9 times -1 is -9 plus 4 is 5. So we have the point x equals 0, y equals 5. This is your y-intercept. So those are all the things you need. Now you can graph these things using all that information. This is what it will end up looking like, and let's double check some of our points here. So on our linear one, we had an intercept of -4. I guess we didn't look at the x-intercept, but that's simple enough to do. This one, we had a vertex of 3 and 4. We had x-intercepts at 1 and 5, and we had a y-intercept at -5. And I think oops, that should have been a negative. -9 plus 4 is -5. My mistake. Okay, so that's it for those ones. Now, second part of your warm-up, determine the value of each of the following. F of -3, so all we're doing is instead of an x, we're placing this number in there. So f of -3 is simply -3 all squared, and then -3 times -3, and the value is 9, and then -3 times -3 is +9, so 9 plus 9, and your answer 18. So try it again with this one. Where the x is, we plug in a 5 instead, so we get 5 squared -3 times 5, so 25 minus 15. Your answer is 10. 2x in this one instead of x, so we get 2x squared -3 times 2x. So wherever you see an x in here, you just replace it with 2x instead. So we get 4x squared minus 6x, and that's as much as we can simplify it. So example 1, we want to determine the sum of two functions. So we're looking at these two functions, f of x equals 2x plus 1, and g of x equals x squared. So A, determine the equation of the function h of x equals f plus g of x. So all we have to do is take our f of x, 2x plus 1, and we add to it our g of x, x squared. And of course, if we write it in descending order of power, x squared plus 2x plus 1. And we see that we get quadratic here. So B, let's take a look on the next page. We're going to sketch this where we'll just do it by hand. Then we'll state the domain and range. So here's some points here to help us out. Let's just see what's going on in our original function f of x and g of x, and then in our combined function h of x. So when x is minus 2, we have 2 times minus 2 is minus 4, plus 1 is minus 3. Similarly, for this one, negative 2 squared will give us 4. Now, in this one, it's the sum of the y values of these two things. So, we simply have negative 3 plus 4, and you notice that we end up with 1. And you could check it out, double check it by plugging negative 2 in here. Negative 2 squared is 4, plus 2 times negative 2, so that's 4 minus 4, plus 1, and that equals 1. Now you find that the sum of the functions is always the sum of the two y values. Okay, so negative 1 plus 1 is 0. 1 plus 0 is 1. 3 plus 1, 4. And 5 plus 4 equals 9. So there you go. You can verify that those are true. Here is what the graphs would look like. So we're going to pay attention to a couple things. We wanted to know what the domain and range are of the new function. And then we're going to determine the values of all these things when x is 4, which will be pretty quick and straightforward. So let's take a look. Domain and range of the new function. H of x, this is the new function right here. The domain, as you can see, this is a parabola. So the domain will go on forever into negative infinity and forever to positive infinity in terms of x values. So x, such that x is an element of the reals, there will be no restrictions whatsoever on the domain. And the range, well, it goes from this minimum point upward. So y, such that y is always greater than or equal to 0, but otherwise has no problem taking on any value within that range, so it's an element of the reals. On to the next one, determining, oh, well, this is the same one. So that's what we just discovered. The value of f of 4, g of 4, and h of 4, this is pretty straightforward. So just plug in 4 wherever you would see an x in the original function. So 2 times 4 is 8, plus 1 is 9. The next one, x squared, plug in 4. 4 squared is 16. The next one, plug in 4 into this one. Now you know that we should get the sum of these two things, 9 and 16. And as it turns out, 4 squared is 16. 2 times 4 is 8. Add them all up, and we get 25, which is the sum of those two things. So here's your turn. Hit pause, give it a try. The answers will be available when you unpause the video. So there are your answers. Hopefully you are able to work that out. So let's try the difference of a couple functions here. So let's consider these functions. The root of x minus 1, and then g of x is just x minus 2. So determine the equation of the difference of these functions. So all we have to do is take our f function, the root of x minus 1, and we subtract the whole of our other functions. So that's why I put it in brackets here. So then this negative sign will get distributed to both of those, and our new function h of x is going to be the root of x minus 1 minus x plus 2. Alright, sketch them on the same set of coordinate axes. So we just use a table of values, find some important points, and I think, I've gone ahead and found the domain of f of x. So because a radicand can never be a negative number, x minus 1 must be greater than or equal to 0, which means x must be greater than or equal to positive 1. We'll see why that's important in a minute. So we can try a bunch of values. Now, we said already that x must be greater than or equal to positive 1. So for these first three, you expect that that's going to happen. All three of these are going to be undefined because they create a negative radicand, and we cannot take the root of a negative. So it doesn't matter what this value is. Our combined function will have undefined values as well. All right, now finally where we have a defined value, 1, so 1 minus 1 is 0, the root of that, of course, 0. And 1 minus 2 is negative 1. So this one should be the difference of these two things. So 0 minus negative 1. Because we subtracted this one from this one, we state this one first, then subtract the y value there. 0 minus negative 1 should give us a value of positive 1, and sure enough it does, and you can go ahead and test that in here. 1 minus 1, this is 0, and then negative 1 plus 2 would give us positive 1. So similarly, the rest of our values follow suit. 1 plus 0 is 1. 1 minus 0 is 1. 2 minus 3 is negative 1. And 3 minus 8 is negative 5. So those will help us graph all three of these functions. And this is what they end up looking like. So here's our combined function, or our difference function right here. And we have a few important points. So we'll pay most attention to this for our domain, and then this maximum right here for our range. And I've actually gone ahead and graphed these on Desmos so we can actually pinpoint those values. So here is my combined function. So our range is going to be from 1.25 down, and that will go on to negative infinity. So y will always be below this value. And our domain, so we have the tip of this thing is at 1 and 1. So the x value of 1, it will never drop below that. It will always be 1 or greater on in that direction. So the domain, x is greater than or equal to 1, otherwise an element of the reals. That's of our original f of x function. This one has no restriction on the domain, but our combined function has the same restriction on the domain as the original f of x here. So it consists of all the values that are in both domains. So this is the important thing. All the values in this domain must be in both, not one or the other, but both of the original functions that it's composed from. So this represents the domain of f of x. It goes from here up. The domain of g of x is everything. So the domain of h of x can only go from here up. So it's all the values contained in both of these domains, which is all of those. From the graph, the range appears to be approximately y is less than or equal to 1.2. We found out that it's exactly 1.25, otherwise an element of the reals. So here's your turn number 2. So take a look, pause the video, give it a try. Of course, as usual, the answers will be there when you get back. Okay, this is a big one, barely fits on the page here. There you go. Okay, example 3. Sketch the graph of h of x given the graphs of f and g. Okay, so we are adding the sum of these two, finding the sum of these two, and we are trying to sketch the graph of the new one based on just these two. Now there are two ways to do this. The first way is just list a whole bunch of points and then add the y values and get the new points for the new graph. So if we choose a whole bunch of x values and plug them into both of the original equations, we can easily find the new value for the combined, the sum equation here. So -3 plus 1, -2. -2 and 0, -2. Find that all of these end up being -2. So this, our new function, is just h of x equals -2. Okay? So it's a horizontal line. There's another method. You could first determine the equations of the other two things. So these are just linear, so we can easily take a look at these. Now this blue one, f of x, this has a slope. We go up 1 over 1, up 1 over 1. So it has a slope of 1, so 1x, and then a y-intercept of 1. So this is 1x plus 1, or just x plus 1 as we would traditionally write it. Now g of x, this one, obviously it has a negative slope because it's going down from left to right. And again, it's 1 and 1, 1 and 1, 1 and 1. So it has a slope of -1 and an intercept of -3. Now, what we're doing to find our h of x is the sum of these two. So we start off with x plus 1, and we add -x minus 3. So x minus x is just 0, and then we have 1 minus 3 equals -2. So there you go, and just as we found with our other method, h of x is a horizontal line at y equals -2. So if you want to see that again, you can just pause the screen here and look at all of this, and you could verify it all on Desmos. So here's another your turn. Go ahead and give it a try. Very similar to what we just did, except we are doing a difference function here. So same two original ones, but a difference function. There's your answer. There's the sketch of your new function. Finally, an application for this. So Reach the Top is an academic program. Now the cost of t-shirts for the program includes $125 in fixed costs and $7.50 per t-shirt, but they're sold for $12 each. So A, write an equation to represent the total cost as a function of n, the number of t-shirts. So the cost is going to be $125 fixed cost that you have to pay no matter what, and then $7.50 per t-shirt that you have made. So $7.50 times the number of t-shirts that you have made, which is represented by n. The revenue based on the number of t-shirts sold, well, all you're doing is selling each t-shirt for $12 a piece. So however many t-shirts you make, you're going to get $12 of revenue per t-shirt. So the revenue function is just 12 times n. Graph the total cost and revenue functions on the same set of axes, and we'll see what happens. So let's take a look at what does happen. So graph these all up. And you'll notice that we have an intersection here, just around about 27 and 325. So 27, 325. Now, what does this mean? Well, 27, this represents the number of t-shirts, and 325 represents basically the revenue from the t-shirts, but also the total cost. So since they intersect, they both have that value when x equals 27. They both have a value of 325. So the point of intersection represents the point at which the total cost equals the revenue. So that means it's the break-even point. So anything above that, you'll notice that the revenue line, the red line, because it has a steeper slope, because they were selling the t-shirts for $12 and then we only cost us $7.50 to make them, everything above this will be considered profit. So profit can be represented by the combined function if we subtract the cost function from the revenue function. So whatever revenue we make, we subtract the cost from it for making all those t-shirts, and we the result is profit. So this is the profit function, and you notice that we are just 12n minus 7.5n will leave us with 4.5n, and we can easily figure out what each number of t-shirts made and sold, what profit that will result in. So the domain of the new function, you can go ahead and graph this on Desmos or a graphing calculator, and you'll find out that the domain has to be greater than or equal to 0. You cannot make negative numbers of t-shirts, and it must be an element of the whole numbers, because we're not going to make half t-shirts either. So that's the original cost function. The domain of R, the revenue function, again, can't make negative number of t-shirts, so that's it. And the domain of your profit function, it's the exact same thing. We're not going to make negative numbers of t-shirts. So here's one for you to give a try to. So you can go ahead and hit pause, and the answer will be ready for you when you come back. So hit pause now. There's the answer. So here's your cost function. Here is your revenue function. Here's your profit function, which is obviously the difference between the two. And then here's all three graphed. So cost function, revenue function, everything above this will be profits. So you notice your profit function does not have positive values until we reach that intersection there. And this is all profit. Okay. There are your domains. Awesome. That's it. So, have a good night. See you in class tomorrow. Say hello to the pre-calc girls, Ella. Hi.